sum will give us the same value, okay? A plus B and B plus A are the same, okay? This property is called commutative property of addition, okay? Commutative. The sum of any two rational number is commutative. The third property in addition of rational number is A plus, in the bracket, B plus C, and A plus B plus C are the same. Okay, take any three rational numbers. Okay, this property holds. How do you check whether this property holds true or not? Find the sum of the two rational number, B and C, and add the number with A. Then go to the right-hand side, add A and B first, and add that result with C. Okay, so this property works for any rational number, and this property is called associative property of addition. Okay, this property is called associative. The fourth property in addition is there is a zero property which is called additive identity. Okay, A plus 0 and 0 plus A are the same. Its result is A itself. Okay, in this case, 0 is called additive identity, or we call it zero property. Okay, this is the fourth property. And the last property in this addition of rational number is for any rational number A plus minus A gives us 0, or minus A plus A gives 0. Okay, so in this case, minus A is called the additive inverse of A. Okay, so these are the properties of rational numbers associated with additions. Okay, so next we will see subtractions of rational numbers. Okay, when we come to the second operation, already we have seen how to add rational numbers. Next, we have subtraction of rational numbers. Okay, when we come to subtraction of rational numbers, say we have two rational numbers, A over B and C over D, where these denominators are non-zero. Okay, A over B minus C over D can be calculated using the principle of cross product. Okay, that is one way. You can have also some other ways by taking LCM. For the time being, I'm focusing more on the cross product just to save our time. So if you are asked to calculate the difference between these two rational numbers, using cross product, you can multiply A with D. It becomes AD minus B with C. It becomes BC over B times D. Okay, this will be the result. Okay, if you remember in our discussion of addition of rational numbers, the sum of two rational numbers is again rational number. That property is called closure property. There is also a closure property on subtraction of rational numbers, meaning that the difference between two rational numbers is a rational number. Okay, you can take any two rational numbers. Their difference is always a rational number, so there is a closure property in the rational number. But when you come to the commutativity, associativity property, and the rest, that property do not work for subtraction. There is no commutative property in subtraction. A minus B and B minus A are not the same. So we can say only there is closure property in subtraction. saying this, let's see some examples of subtractions of rational numbers. Okay, sometimes we call it differences and subtraction. Okay, we use interchangeably these words. So let's see how to find the difference between the following rational numbers. The first one is 29 over 5 minus 4 over 5. Okay, if you are asked to calculate the difference between these two fractions, as you can see here, these two fractions have the same denominator, so you don't need to take the cross product. That doesn't mean that cross product doesn't work. It works, but you don't need to waste your time by taking the cross product whenever you have the same denominator. So in this case, you can take only their denominator and take the difference between the numerators, 29 minus 4, which is 25 over 5. This can be your answer, but this can be further simplified to some number. 25 over 5 is 5. Okay, you can stop here, but don't forget to write your answer in the least simplified form. So this is the result. Okay, let's see some other examples on differences or subtraction of rational numbers. 4 over 5 minus 1 over 3. Okay, clearly these two fractions are fractions having different denominators, so we can apply this procedure. Okay, the procedure that I stated here. So this gives us, we multiply 4 with 3, 4 times 3 minus 5 times 1. Okay, so the denominators are 5 times 3. Okay, this gives us 12 minus 5 over 15. This 12 minus 5 is 7, so the result becomes 7 over 15. You cannot further simplify 7 over 15, so you can put your answer as it is. Okay, so this is how we calculate the difference between two rational numbers. Okay, so our next point of discussion is about multiplication of rational numbers. Okay, multiplication of rational numbers. Okay, when we come to the multiplication part, sometimes we call it product, okay? The product of two rational numbers or the multiplication of two or more rational numbers. So we use these terms interchangeably. So when we come to the multiplication of rational numbers, let's say we have two rational numbers, A over B and C over D, where don't forget to put a restriction on the denominator always, otherwise the numbers will not be defined, okay? So B and D must be a number different from 0. So the multiplication of these two numbers, A over B times C over D, is defined as A times C over B times D. Okay, whenever we are multiplying two rational numbers, we usually multiply numerators with numerators and denominators with denominators. Okay, this is the procedure to calculate the product of two rational numbers. Okay, the same principle works if you have two or more rational numbers. So let's see some examples on multiplication of rational numbers. Find the product of the following rational numbers. Okay. In our first example, we have minus 3 over 11 and minus 4 over 15. Okay, here we have two rational numbers. Both of them are negative. So before I start calculating the product of these two rational numbers, I have to tell you some of the principles associated with the product. Okay, if we have two positive rational numbers, the result of the two numbers or the result of the product of the two rational numbers will be positive. Okay, if both of them are positive or if both of them are negative, the product of the two rational numbers will be positive. But if one of the two rational numbers is negative and the other is positive, the product of the two numbers will be negative. Okay, you need to keep in mind this principle. Okay, so let's see how to calculate these two rational numbers. Okay, minus 3 over 11, okay, minus 3 over 11 times minus 4 over 15. Okay, so you multiply numerators with numerators and denominators with denominators. Minus 3 times minus 4 is positive 12, and you multiply 11 with 15. So the product of these two numbers gives us 12 over 165. Okay, sometimes this answer may not be available in your choice if the question is given in the form of multiple choice. Okay, so you need to further simplify this number into the least simplified form. Okay, you can cancel this one by 3 and this by 3. The result becomes 4 over 55. It's around 4 over 55. Okay, so this is the procedure to calculate the product of two numbers. Okay, let's see another example. Okay, here you are asked to calculate the product of 7 over 15 and 2 over 3. In this case, we follow the same procedure that we used in the first case, or you can directly apply this principle. Okay, so multiply numerators with numerators. Okay, 7 over 15 times 2 over 3 is exactly the same as 7 times 2 over 15 times 3. This becomes 14 over 45. Okay, so this is how we calculate the product of two rational numbers. Okay, sometimes the rational numbers may be given in the form of mixed fraction. Okay, say the rational numbers are 2.5 and 3 and 1 over 4. Okay, if you are asked to calculate these two mixed fractions, if you are asked to find the product, the first thing that you need to do is you need to convert this mixed fraction into improper fractions. Okay, so 2.5 is exactly the same as 5 over 2, and 3 and 1 over 4 is exactly 1/3 over 4, 13 over 4. So the product of these two can be expressed as 5 over 2 times 13 over 4, and 5 times 13 is around 65, and 2 times 4 is 8. Okay, so this is how we multiply rational numbers. Okay, saying this, I will tell you, next I will tell you the properties of product of rational numbers. Properties of product of rational numbers. Okay. If you remember, I stated some properties of addition of rational numbers like closure-ity property, commutativity, associativity, property of zero, and additive inverse, right? Here, similarly, we will have some properties associated with product of rational numbers. Say, let A, B, and C are an element of rational number, okay? Assume these three numbers are an element of rational numbers. The first property that we have is closure-ity property. A times B is also an element of rational numbers, okay? You can take any two rational number. The product of any two rational number is, again, a rational number. And this property is called closure-ity property, okay? Closure-ity property. So the product of rational number is closed under multiplication. The second one is commutativity property. A times B and B times A are the same for any two rational numbers A and B. And this property is called commutative property. Okay, commutative property. The third one is associativity property. There is an associative property on multiplication of three rational numbers. A times B in the bracket, B times C is the same as A times B times C, okay? This property is called associative property, okay? Associative property. The fourth one is there is a distributive property of multiplication over addition. That means A times B plus C is equal to A times B plus A times C. Okay? This property is called distributive property. Distributive property. And we have also some other properties like multiplicative identity, okay? That means A times 1 and 1 times A are the same and its result is A. This one is called multiplicative identity. If you remember, we have seen the additive identity in the case of addition, okay? So when we come to the multiplication part, there is a multiplicative identity. So that multiplicative identity is 1. Okay, so these are some of the properties of product of rational numbers. Students, you can easily verify all these properties by taking three rational numbers, okay? I recommend you to check all these properties holds by taking your own example, okay? So these are all about the properties of product of rational numbers. Now we are left with one more operation, which is about division, okay? Okay, the last operation is division. We have seen the first three operations like addition, subtraction, multiplication, and we are left with one more operation, which is about division of rational numbers. Okay, if we have three numbers, A, B, C, okay, probably those numbers can be an element of rational number, because we are discussing operations on rational numbers. If you have three numbers A, B, and C, which are an element of rational numbers, we use this symbol to represent division. A divided by B is equal to C. Okay, you are familiar with the different operation symbol. Okay, we use this symbol to denote division. Sometimes we use slash to show division. Okay, so before we go to the discussion on divisions of rational numbers, I want to tell you some terminologies associated with division. Okay, in this division, A is called dividend. A is called dividend. And B is called divisor. B is called divisor. And C is called quotient. Okay? You need to be familiar with different terminologies associated with divisions of rational numbers. So whenever I say dividend, you understand that I'm talking about this number, divisor, B, quotient, C. Okay. After saying about some of the terminologies, there are also principles in division. If both A and B are positive, the quotient C will be positive. If both A and B are negative, the quotient C will be positive. Okay? C will attain its positive value whenever both have the same sign. But if A and B are numbers having different sign, that means if one is positive, the other is negative, the C value will be negative. Okay, you need to keep this thing in your mind whenever you do divisions of rational numbers. So let's see some examples of divisions. Okay, let's see, say we have two rational numbers, 9 over 16 and 9 over 16 divided by 3 over 4. Okay, if you are asked to calculate this division, 9 over 16, okay, this is a division symbol, okay? 9 over 16 divided by 3 over 4. Okay, if you are asked to evaluate this thing, you need to follow this principle, okay? Here is the principle. If we have any fractions A over B divided by C over D, okay, where these B, D are different, at the same time C should be different. Otherwise, this operation will not be defined. Okay, whenever you have divisions of this kind, okay, do this principle. A over B divided by C over D is the same as A over B times D over C. Okay, don't forget this thing. Whenever you have this kind of division, to change this division into multiplication, you need to take the reciprocal of the second fraction. Okay? Taking the reciprocal of the second fraction will change the operation from division into multiplication. So, as we have seen earlier, we know how to multiply two fractions. Okay? A over B times D over C is A times D over B times C. Okay, so this is the basic principle that you need to follow in calculating divisions of rational numbers. Okay, so based on this principle, if you want to evaluate 9 over 16 divided by 3 over 4, you need to write this thing in this way. 9 over 16 times, I have to change this division into multiplication by taking the reciprocal of the second fraction. This becomes 4 over 3. Now, this result gives us 9 times 4 over 16 times 3. And this becomes 36. 9 times 4 is 36. 16 times 3 is 48. Okay? So this can be your answer. But still, this can be expressed in another form using some sort of simplification. Okay? By 4, this is 9. By 4, this is 12. Okay? So, still, this can be simplified. Okay? You can further simplify 9 over 12. By 3, 3. By 3, it's 4. Okay? So, this can be your answer. This can be your answer. And 3 over 4 can also be your answer. So this is how we multiply, we divide two fractions. Okay, let me give you one more example regarding division of rational numbers. Say we have 5 and 1 over 3 divided by 8, 5 over 6. Okay, if you are asked to divide these fractions, the first thing that you need to do is converting this mixed fraction into improper fraction. Okay, the improper fraction form of 5 and 1 over 3 is 16 over 3 divided by 8 and 5 over 6 is 53 over 6. Okay, now using the principle that I stated here, you can write this in this way. 16 over 3 times 6 over 53. Okay, so now it is easier to put your answer. Multiply 16 by 6, the result becomes around 96. And 3 times 53 is around 159. Students, you will correct me if I'm mistaken. I'm calculating the numbers orally, but you need to focus more on the procedure of finding the ratio of two fractions. Okay, so this is how we divide two fractions. Okay, students, this is all about operations on rational numbers. We have seen the 4 basic operations on rational numbers, and we have also seen the properties of rational numbers, like properties on addition, properties on multiplication, and some other things. Okay, I hope you enjoyed the lesson. You have some more homework regarding the point that we have seen so far. Okay, here are your homework. You need to do all the questions briefly. Evaluate the following rational numbers. Number 1, 4 over 9 plus 19 over 9. The second one, 3 and a half minus 2 and 1 over 3. The third one is calculate the product of 11, 4 over 5, and 3, 1 over 4. The fourth one is do the operation 7, and 6 over 7 divided by 3, 6 over 7. Okay, try to evaluate these four questions. All of them are questions taken from the 4 operations. I hope you enjoyed the lesson. This all for today. Don't forget to do all the homeworks. Thank you for watching.
Hello. How are you?
I'm good.
What's your name, please?
My name's Journey.
Love you.